Hello everyone, this is Akash from the Big Data Guy and welcome to your 6-part tutorial. In this video we are going to cover FlatMap, Coalesce and group by function in RDD. So let's get started. So open up terminal and let's start Jupyter Notebook. So for that we are just going to say PySpark and we have started it. Okay, we are just going to create a new notebook. So we have already covered map function and you all know what a map function does. Flat map is not much of a different function from map function. The only difference between a map and a flat map is that both of them basically applies a particular operation to each element within an RDD, but map function returns the output as it is. However, as the flat map function suggests, flat map function would return a flattened output of the RDD. So here's what I mean. I'm gonna illustrate it by an example. So suppose that we have like list. Let's say we have numbers 1 2 3 4 5 6 7 8 9, and we are going to make it into an RDD by parallelizing it as c.parallelize. Oops. Yeah, this is right function x, and then we are going to take 5 and see what happens. So as you can see, we have already formed an RDD of the list x, and now we are going to use the map function. So suppose we want to multiply each number by a number plus 1. So let's say series is equal to rdd.map lambda x. For each of the x, we are going to return the number x, and we are going to also return x plus 1 into x, and that's basically it. And then we are just going to print series dot collect. I have misspelled series, I think. So yeah, so here's what we have got as a result. You can see 1 is equal to 1 plus 1 into 1, 2, and then 2 is equal to 2 plus 1 into 2. Sorry, we have messed up. This should be in the brackets. Operations, guys, operations, you have to be pretty careful with the precedence, operation precedence when doing such operations. So yeah, so now we arrive on the series, and here we go. This makes sense. And now let's just do the same thing, but the only thing we are going to do is we are going to change map into flat map, and then we are going to see the result. And if you see the result, you can see how the list is flattened out. Basically the output is flattened out after the map operation. So one might question, why do you want to use flat map? I mean, it doesn't make sense. It makes sense to have a list in such kind of operation where you want to know that, hey, for this number the output is this, for this number the output is this, so for this number what will be an output, like, this is what makes sense naturally. But suppose that you have something like state names. So suppose you have a state city where you have like suppose you have New York State, and within New York State you have Syracuse, Rochester, and Albany. And then you have another state called a province of Canada, British Columbia. and you have cities like Vancouver, then Surrey, and Burnaby, and so on. And let's say we form an RDD and we have something like this. So when we form an RDD and then we take two elements for the sample, you realize that we have something like this. But instead, what we want to do is we want to map state and city, state and city, state and city. We want to flatten this out because like we don't know how many columns is this table going to have. We want to store it much more in a better way instead of storing it into a list for the purpose of accessing it properly. And if you want to do that, what you can do is basically just do like a flat map on it. So let's do this. rdd.flatmap lambda x, where you're going to return. Oh, hold on. Sorry, we have to write a function. This is a bit complicated, so that you understand properly. You can write it like that, but I just want to know, so that I just want to show you guys what we are going to do, how FlatMap is going to be useful. So let's say flatten the list, right? And then we are just going to return a new list, and then for state is equal to list of 0, and for LE in list of 1, we are going to have new list dot append state comma element, and then return new list. So for your information, let's just run this example quickly so that you understand what's going on, what a flat function does, and print. So what it does is it basically returns a state name and a city name, state name and a city name, state name and a city name, and basically it's a list of list. Now suppose that if we use a map function on this and say map flat dot collect, and then we use flat map function on it and then collect, and then you will see the difference. So in the first one, you can see that what it forms is it forms a list of a list, which is basically for New York State. Inside there's a list which is New York Syracuse, New York Rochester, New York Albany. And you want to access this list, it's a bit complicated because it's a list of a list of a list to access a particular city within a state. But when you use flat map function, you can see it's flattened out. It's basically much more easier to access. And I'm sure you can find some more application of this, but this is somewhat of simpler application. I hope you get what we are trying to do with the flat map function. Now the second function that I want to cover is something called Coalesce. So suppose that we have a list. We are going to say that we have a list of, like we have a state name, fine, and then we have New York, California, and I'm not sure if Dakota is a state. I guess it's a state, sorry. And then British Columbia. Now this is pretty simple. This is a small list. Suppose if you have a very large RDD, if we multiply this by 25,000, and then we basically say the length of state name, you can see it's a huge list of 100,000 element, and we are going to basically create an RDD out of it. So we are going to say state RDD is equal to sc.parallelize state names, and then we are just going to take 5 state, and then you can see like it's basically a repetitive, let's say 8. So it's basically a repetitive state names that's going to appear for 100,000 times, which is, sorry, 25,000 times. Basically New York, California, Dakota, and British Columbia 25,000 times each within this RDD. And suppose we want to save this. Save text. State RDD.save text. We are going to say state names, and then we say, oops, oh, I forgot how we save the files in PySpark. So we are just going to find that out quickly from the documentation, and then I'm going to show you how to read this documentation as well. So save as, save as, oh, save as text file. So I was right, it was not save text, it's save text file, save as text file. And then you can see here in the result the state name, and then we have 4 different parts. Now you don't want to be going and basically combining this for output when you are trying to write such large RDD into a text file. You want to have a single file so that you can send output to someone whom you desire, so that they can review. Suppose that someone is asking for a business report in your company and you want to run some quick Spark job and send results. You don't want to be doing some more data operations to combine these files and send it over. You want to save time, and to do that, Coalesce function is going to help you out. Coalesce 1. So what this says is that this is going to coalesce this whole output into one single file. So let's do that again. C-O-L-E-A. I guess I misspelled it. C-O-L-E. Coalesce. This is how you spell it. There we go. So we coalesce the whole RDD into a single part, and then you can see in the result in state name 1 we only got one part. And what if we did 10, coalesce it into 10 different parts, and then save it as text 2? And now you can see that if you want to save your entire huge output into 10 different files, well, it's not able to save it into 10 different files. It's only able to save it into 4 different files. But instead, like if it was a very large file and you want to save it into 10 different files, you can do that. But here I'm just going to show you another example where instead of, oops, this directory already exists. So if instead of saving it into 10 different files, let's say you want to save it into 2 different files, you can definitely do that. Our data is not that large to be able to save into 10 different files, and that's why we are not able to get 10 different files. We only got 4 different files. So I am running out of time in this tutorial. So let's do the group by and how to read documentation in next tutorial. So thank you for watching the tutorial. Please like the video and subscribe to my channel for more tutorials. Thank you. Bye for now.